So this last video in this section, we're going to do something called trigonometric substitution. This is used a lot in calculus to figure out things called integrals. So trigonometric substitution usually uses one of the Pythagorean identities. Cosine squared theta plus sine squared theta equals 1. It is often written as 1 minus sine squared theta equals cosine theta. I just put the sine squared theta on the right, and then I flip them. So that means the same thing. You could also do 1 minus cosine squared theta equals sine theta. It doesn't matter. Comes out the same, works the same way. Then there's the 1 plus tangent squared theta equals secant squared theta. We don't usually use for this the cotangent cosecant one because they're of the same form. So you just need one of them. So it's more common to use this one. Okay, which could be written secant squared theta minus 1 equals tangent theta. Notice the difference here. Over here, we've got 1 minus something with the variable, and here we have some squared, and here we have something with the variable squared minus 1. And these are very different. So, for example, square root of x squared plus 1. The trig substitution, you could set x equal tangent theta. It's a substitution. And then you get square root of tangent theta plus 1, which is the square root of secant squared theta. And that's the absolute value of secant theta. And if you know that secant theta is positive, then it's just secant theta. So you've taken this algebraic expression here and changed it to just a single trig function. So that would be a substitution. Now, if I had 1 minus x squared, then I would use this one. 1 minus something squared. Right? So we'd get, so that's setting x equal to cosine theta. Then we get 1 minus cosine squared theta, which is square root of sine squared theta, which is the absolute value of sine theta. Now, if we know we're in quadrant 1 or 2, then we don't need the absolute values because the sine theta will be positive, right? If you know you're in quadrant 3 or 4, then you just drop the absolute values and put a minus in front. Okay. Now, what about 9 minus x squared? Well, here we set x equals 3 cosine theta, because then when you square 3 cosine theta, you'll get 9 cosine theta. The 9s will factor out. So, right, like that. And so you get the 1 minus cosine squared theta, which is sine squared theta, with absolute values, right? So that's how you handle that. If we know that theta is between negative pi over 2 and pi over 2, that is in quadrant 1 or 2, then secant theta is greater than 0, because it's 1 over cosine theta. Wait, secant 1 over cosine. Yeah, right. Because it's 1 over cosine theta. So absolute value of secant theta would equal secant theta. Just making that point. Sometimes you can just drop the absolute values and make it simpler. If we know that theta is between 0 and pi, then sine theta is greater than 0, so the absolute value of sine theta equals sine theta. Right, so that's just saying those absolute values could be simplified if we know certain things about the angle. Anyway, that's it. We're not going to do it. You might wonder, why would we want to do that? It's for something that we call integration, that you usually you would do this in Calc 2. So it's just so that you've seen it before, so when you get there, you won't get, you'll say, oh yeah, I kind of remember that, and then learn it really well at that time. at this time, we're just doing the substitutions. So that's it for that section. Not too long.